Okay, Managing the Challenges of High Frequency by Martin Pfrommer, GD Satcom. That's General Dynamics Satcom Technologies.
Thank you very much.
Wish you well, Martin.
So, hello everybody, also from my side. I'm very happy to see that still so many people here that want to hear about antennas. My experience in life is most people don't like antennas, but they like services. So the services, you need antennas. So at the end, they're still there. And in fact, what my headline for the presentation is Antennas for the Future Communication. There's maybe a little bit of misalignment happened, but high frequency is definitely a topic. So as the antennas are going to stay in future, and I'm talking here particular about parabolic type satellite antennas, I would like to show you a little bit what I believe that the antenna's going to look like in the next, let's say, 10 to 15 years. The first slide's not a big surprise. This is just geostationary satellites. They need ground segment. And as you can see in the bottom row, all good antennas designed several years back. The first kind of funny-shaped antenna is even designed here by our chairman, Mr. Barry Watson. Several of the other antennas here as well. I'm pretty sure they're going to stay. Frequency ranges typically between C and dBs band, could be going up a little bit, and a little bit changing back and forth depending what the actual regulation allows. I think they're going to be important for the next many years because even a traditional satellite has a good option to bring an information into a big area to a big amount of people, and such a communication tool stays important in my opinion. Also, traditional satellites allow, as it's illuminated, a big area, if you have disaster issues, going somewhere, establishing a communication link with kind of deployable terminals like we see in the upper row. These are kind of antennas with modem RF electronics already included. What I don't show is vehicular type antennas or tripod antennas, which give a little bit of higher flexibility. I'm pretty sure all of the antennas that we've seen over the last 10 years, you will see in the next 10 to 15 years as well. Now there was a higher demand, not just receiving signals, but also to communicate two-way. We already heard about that, that the solution is high throughput satellite. High throughput means you need more bandwidth, a lot of data is now requested, higher frequency so that we have more bandwidth. That means you need to have an antenna that is capable of the higher frequency and it is capable of a high throughput, high bandwidth, so the antenna needs to be big. And it turned out that the 9 and 13 meter antennas for gateways were quite successful. We've sold more than 100 of these. We've seen already some previous presentations where you saw our antenna, and I'm pretty sure this type of thing will continue. You're going to see that also in future. That's an important antenna. Now, some operators, high throughput operators, they have sometimes financial challenges. They want something cheaper, and as a company we also want to address these kind of requirements. You're gonna compromise in technology, so this antenna is a cheaper version, but you have challenges like if you do maintenance, you need to go out of service. The structural stability is not as high as the one that is already established in market. So you see a little bit more of signal fluctuation, but I'm pretty sure over the next years you're going to see this type of antenna in areas where cost effectiveness is a bigger topic than availability of the service. Now, if you want to get even more out of your high throughput system, you free up your bandwidth by putting your uplink to Q and V band. We heard a lot of that already. Q and V band already existing in antennas. This is an example of a test antenna. So this antenna that you see here, you're not going to see very often in future, I'm pretty sure about that, but it's an existing and already working 3-meter type Q and V band antenna installed in Austria. And what you're going to see in the next future, in my mind, is antennas like these. These are now 7 and 9 meter Q and V band antennas. And even their drawings, they're already in production, so we're going to see them definitely over the next years. Now, I hope that satellite operators can operate their satellites better than I can do my animation in the presentation. We already heard there is other challenges coming up. There's no slots in geostationary anymore. You want to have lower latency, other things. You want to get the satellites closer to Earth. And a good idea is doing that in an equatorial orbit. That gives you the advantage that the satellites are coming up from the Earth always the same way. So it's always the satellites coming up exactly in the same place and it's disappearing in the other place. And that gives the opportunity to put antennas up with a polar mount system, so one axis driven. O3b is the example here. Thanks, SES. Here we see a system like used currently at O3b. And this is quite a good idea of operating satellites closer to the Earth. We're going to see more of such antennas, I'm pretty sure, kind of polar mount type antennas. If you take the system further, it's going to be LEO satellites, even more. Now they're flying everywhere. You cannot tell exactly anymore where they're coming, where they're going. You need a program track, and a cost-effective way of doing that is XY mounts. And this here is an example, a prototype. Nothing you're going to see over the next years that looks exactly like this. This is a system that we took to play around, understand the challenges. This is a 1.2 meter antenna. We used a completely new type of composite material to do a lightweight reflector. Has kind of the same properties like a carbon fiber one, but we can do it in a press, very nice. So the whole thing is only like 2.5 kilograms in weight, the reflector, and so we did several tries with that. So in future, we're going to see definitely much more XY antennas to support LEO-type constellations. One thing I want to show with this slide is, if you think Q and V band is high frequency, you're absolutely right. It has a lot of challenges in communication, but it's not necessarily a big challenge for us as an antenna manufacturer. Here you see a 12-meter antenna. It's going up to 1 terahertz. Don't get me wrong, it's not a communication antenna. It's just an example that the ground structure can be built to this type of specifications. What we do as a company for high throughput satellites, however, is we're going to support also the electronic side. So we see here a very high power amplifier to support quite a lot of data. You can also see here LNAs that are designed for extreme harsh conditions or extreme wideband Ka-band LNA, things like that to support the high throughput industry with the right products. We spoke about reliability before. One thing is definitely that you have quality products. The other thing is if something happens that there is support. We at GD are kind of proud that we believe to be the only company that has a 24/7 hotline for our customers whole year through. You can call us all the time if you have a technical problem, and that just comes as a standard with every product we sell. And finally, if there is a business challenge somewhere, we have a program called Ready to Go, so that you can get most of the typical products from us in 30 days' time. Now that's it from my side. What I'd be very interested in is if we meet again, let's say, in 6 to 10 years here, I would really appreciate that, and then review my presentation and see if my promise went right or if I was wrong. Thank you very much for your attention.
Martin, you did very well. Thank you. Well done.
Thank you very much.
Yeah. There you go.
Pleasure.
That's for you.